practice problems. So I just made a video and did the whole thing, and my mic didn't work. So here's step two. That really drove me nuts. Okay, I've got everything written here though. I'll just kind of go through what I've done. So the first one says a 5 kilogram object is attached to a rope. What is the tension in the rope if the object is traveling at 6 meters per second in a circle with a radius of 4.5 meters? So I wrote down on the left what I had and what I was looking for, and then really looked back to my formula sheet to see which one I was going to need. So in this case, so I had mv squared. So I really just plugging it straight in on that one. So just kind of look to see what I've done there. Number two, if a centripetal force of 80 newtons causes a 6 kilogram object to travel in a circle once every 0.5 seconds, what is the radius of the circle? And then what is the speed of the object? So what we had to do though was kind of recognize here that when it says traveling in a circle once every 0.5 seconds, that's talking about period, right? That's what period means. Like how long does it take to do one circle? We had FC, we had mass. I chose the formula that had FC, mass, and period, and then rearranged to solve for R, and then just plugged in the numbers, and then R was equal to that. We're going to be doing a lot of rearranging here, so if your skills with rearranging formulas aren't quite there, I would definitely practice a lot of these. Okay, and then last I said, okay, I'm looking for V now. So I looked to my formula sheet and I said, okay, well, this one has V in it and F, and now I know R. So I used this formula here. And then rearranged to solve for V and got 1.6 meters per second. All right, 3. A force of 45 newtons causes an object to travel in a circle with a diameter, that's why I underline that, is because that's not a radius, of 7.5 meters with a frequency of 0.6 hertz. What's the total mass of the object? So figuring out what I know here, what I did was wrote down FC because I know that one. R is going to be half of the diameter, right? Diameter is all the way across the circle. So I took half of that because our equations use R. And then this said a frequency of 0.6 hertz. Well, I know that frequency, or if I want to figure out period, I just go 1 divided by frequency, and you can find period. Or vice versa, you can find the other one easily by going 1 divided by. So now I know the period is equal to 1.67 seconds, and now I'm just looking for mass. So I chose the formula that had FC, because I have it, R, M, and T. So now I just rearrange that for M, and then I didn't actually put the numbers in, but if you do, you should get 0.84 kilograms. Number 4, an object rotates around a circle of radius 4.75 meters. If the object completes 15 cycles in 35 seconds, what is the centripetal acceleration? So what I did over here is I said, okay, we got to figure out what this 15 cycles in 35 seconds even means, right? What we want this to read instead of 15, so I've got 15 over 35, so that's like 15 cycles every 35 seconds. I want to know how many cycles it is every 1 second, because I know what that is. Cycles per 1 second, that's hertz, right? Or that's frequency. So you can cross multiply. If you remember how to cross multiply, you can do that. Or you can kind of look at this and just say, okay, well, x over 1, that's just really just x. And then I just need to solve for x, that's 15 divided by 35. And if you do that, you get a frequency of 0.429 hertz. So now we have a frequency. Period is just 1 divided by frequency. So period is equal to 2.33 seconds. So now I know these things over here are T, and I'm looking for A. I chose the formula that has A, R, and T in it. And then just, if you put those numbers in and solve for A, you should get 34.4 meters per second. Okay, so yeah, sorry that I couldn't have actually shown you as I was writing these things out, but I didn't want to erase it all and do it again. So that's it. One thing though, number 9, when you're doing the practice problems here, in the past I've noticed that people really have a hard time with C, or they kind of forget what's happening here. So it says an athlete whirls a 3.7 kilogram shot put in a horizontal circle with a radius of 0.9 meters. If the period of rotation is 0.3 seconds, and then the last one says, how far would the shot put travel horizontally if it is released 1.2 meters above level ground? This is a projectile problem. So you're going to go back to kinematics at this one. So yeah, just so you have like a frame of reference there. It's going to be one of those ones like going off the side of a cliff. Number 10, we didn't do a practice problem like number 10, but example number 6 is really similar to that one. So if you want to write that down on there, like example or C example 6. And then 11 and 12, I'll let you guys see if you can figure these out on your own. So that's it for the assignment problems or the hand in assignment. And I guess I'll see you guys in the next lesson.